Okay, hello everyone, Tony here. Today I would like to demonstrate that TiDB will have zero downtime or zero impact on a client's business, even when facing an availability zone level failure on a public cloud. So to understand this demo, you only need to have some very basic TiDB knowledge. So firstly, we assume that you know that TiDB is a distributed database. And then secondly, you need to understand that TiDB consists of the TiDB server, which is a SQL layer, the TiKV server, which is storage layer, and also the PD server, which is a metadata layer. Let's now look at all the terminals on my screen. So two terminals on the upper left corner show our simple workload. On the left one, you can see there are two workers inserting data into the TiDB. Two workers connected to different TiDB servers. As you can see here, one TiDB server is on 10.90.1.158, while the other TiDB server is on 10.90.2.176. So two workers are now write data to two different TiDB servers. The terminal window in the middle represents a workload that keeps reading from the TiDB database and counts the number of records. So no matter how complicated your customer's workloads will be, it can be represented like this. Okay. I can also pause my inserting workload by using Ctrl+C. As you can see now, the workload has stopped and time keeps advancing in the middle window, but the number of rows does not increase. Let me now restart my workload. Now, I will show you how TiDB is deployed on AWS. In this demo, we use AWS as an example, but it is quite similar on Azure and GCP or Google Cloud Platform. Let's now look at the topology. We have an in-house program to draw topology automatically. We deploy TiDB on AWS within one region, but across multiple availability zones. We should never deploy all TiDB components within one availability zone to prevent the AZ level failure. In fact, this kind of disaster did happen before multiple times on almost every cloud vendor. Okay. Here's the topology. In the AZ US West 2A, we have a subnet called demo subnet-1. Within this subnet, we have one TiDB server, one TiKV server, and one PD server. The TiDB server is stateless, while TiKV and the PD servers are stateful. And in the second availability zone, we have only one TiKV server, one TiDB server, and one PD server. And now in the third availability zone, we have only one TiKV server and one PD server. There's no TiDB server in this AZ, as we only have two TiDB servers. Okay, let's now get back to the first availability zone. There is only one monitor server in this availability zone. There is no data at all. Right now, let's take down an availability zone. It is obvious that the US West 2A is a very important one. So let's now take down this availability zone. I definitely cannot take down a AWS AZ, but I can isolate all components in this subnet by calling AWS API. And by doing that, all components outside the subnet can no longer talk to the components within the subnet. This is exactly what happens when the AZ went down. Let's do it now. Okay, it's done. You can now find that writing clients only talk to the TiDB server with IP address 10.98.2.176, while previously worker 1 and worker 2 talk to either 10.90.2.176 or 10.90.1.158. Two workers are still working, it's just they only talk to one TiDB server. In the second terminal, you can find that the number of rows is still increasing. You should barely feel there's something went wrong. But in fact, one AZ is down. If you look at the cluster monitoring, you can find one PD, one TiDB, and one TiKV are down. Recall that PD is a metadata service, TiDB server is the SQL layer, and the TiKV is the storage layer. Due to the wonderful design of TiDB, there is almost no impact on the frontline business. There is only a few seconds delay. On the other hand, if it's really an AZ level disaster, it is likely that the cloud vendor may take at least 10 minutes, or in sometimes more than 10 hours, to fix it. But if you are using TiDB, there is minimum impact. Let me repeat myself again. Those disasters did happen more than once on almost every cloud vendor. The greatness of TiDB lies in dealing with this kind of disaster as a database, not a stateless application. Many of our customers choose TiDB due to this feature. That's everything for this quick demo. If there are any fundamental concepts which are not very clear to you, such as TiDB, TiDB server, TiKV, SQL layer, storage layer, stateless and stateful, you might consider going to the PinCap training and certification site to enroll and learn the self-paced introduction to TiDB course first. Thank you so much. See you in the next demo.